I'm about to tie some cages for some pilings. So there'll be circular cages that will fit into the pilings that will support the grade beam on a building that I'm doing. I recently lost a building on the farm here to a Saskatchewan windstorm, and I've decided to kind of take it all apart, and I just dug a trench and I'm going to mark out for pilings. I'm going to drill 12-inch pilings. I'm going to place them about 8 foot on center, and I'm going to aim for about 12 feet deep. I'm going to drill them with a skid steer. The pilings will support my grade beam, but I would just like to point out, in case you're wondering about why I would put a cage inside of a piling, or why a contractor would do so. That's because the pilings that are going to be poured, 12 inches in diameter and 10 feet deep in the ground, aren't just for the grade beam or the foundation to sit on. In Saskatchewan here, we have a frost push. And so that frost push is going to get underneath the grade beam, and the grade beam is going to try to get forced upward or lift your building. And that frost pressure is very immense. And so what you want to do, because concrete has very good compressive strength, but not very good tensile strength, you want to use that rebar cage to increase the tensile strength of the concrete. So as the building is getting forced up, you want that building to be tied down into the ground. Now, simply putting a couple pieces of rebar inside the concrete is an okay idea. It's definitely better than nothing. But the problem is that because concrete has such low tensile strength, it will be forced. It will probably crack when it's forced up. So as there's an up pressure from the frost pushing on the grade beam, it's probably just going to split that 10-foot high piling somewhere in the middle, because the concrete will simply split and not be pulling right from the bottom of the piling all the way to the top. So by tying a cage that goes right from the bottom of the piling all the way to the top of the piling, you know that when there is that pressure upwards, that the frost will have to pull that piling all the way from the bottom. And now concrete pilings are, kind of referred to as a friction pile. So people have made mistakes before of, trying to put sonotube down the whole, the whole hole that they drilled. But that's not really what you want to do. You want to use sonotube at the top of the hole, so the frost has nothing to grab, it's nice and smooth. And also just because often your pilings kind of protrude above the ground a little bit, depending on how you excavate it. But yeah, when it comes down to the bottom of the piling, you want it to actually grab the soil and have that friction, for sure. A perfect piling would be one that bells out at the bottom, almost creating a bigger footprint at the bottom. This is possible. In residential construction, we don't really worry about that too much. And since mine is just a little car garage type of outbuilding that I'm trying to do, I'm happy with just a piling that gets below frost and grabs that weight. All right. So to tie these cages efficiently, it takes me 2 bars. I use a 20-foot bar. It's not exactly 20 feet, I think it's about 19 foot 10. There's, I think, a metric measurement that rebar works out to, but 1910 is pretty close in an imperial measurement. So I say 20 feet, close enough. 20 feet, I cut that into a 8-foot and a 12-foot, and I do that twice. That gives me 2 8-footers and 2 12-footers per piling. With a 10-foot hole, this means that 2 of the bars will stick out about 2 feet out of the hole, and then the other 2 bars will simply be in the concrete, helping me with that pull. The 2 bars that protrude up will obviously be tied into the grade beam, so when that grade beam gets that push, it's tied directly to each piling. And I've thought about putting, all 4 bars into the grade beam, but it actually doesn't make too much sense because the grade beam usually is only, residentially about 8 inches, and these cages are 8 inches, so there's no way that you'll ever get all 4 bars into the grade beam. The couple of jobs that I did where I had 4 bars sticking up, I ended up cutting off 2 anyway because they just simply didn't fit into the 8-inch grade beam. Almost done here. I'm using the, these twisters. That's about all you need for something like this. Because I'm not doing no fancy, rebar tie here, I end up going both directions so this thing just doesn't fold over on me. Like so. I have 18 of these to make since I'm putting them about 8 to 10 foot on center, closer to 8. So yeah, in this case, the rebar, simply by being from the bottom of the hole to the top, will keep that concrete with a higher tensile strength. If you're putting rebar in anything else, like a wall or a slab, you want to consider which side of the concrete is in tension. So if it's a slab and you're driving on top of it, the bottom of the slab is in tension. So you want the bottom of the slab to have the rebar cage. And if you're pouring a wall, and that wall is being backfilled, for example, you would want the inside of the wall with the rebar cage because that's where the tension is, where it's being pulled apart. The outside of the wall is in compression, same with the top of the slab. So the placement of rebar is really, really important. Here we go. Got her done. This cage will stand up vertically, so the 4 verts, and 2 of those verts will continue on into the grade beam. All right, 1 done, 17 more to go. Thanks for watching.